Okay, thank you. So I'm Nicolas Rougier. I will present the ReScience C journal. So it has been co-founded in 2015 by me and Conrad Insen. And so the idea of the journal is to publish only replication in computational science. So it's a very restricted. And I will give a few a few words about how it works. But mostly we live on GitHub. And we publish article on Zenodo to get the DOI. And so ReScience in numbers, so it's not up to date, but it's approximately 4 editor-in-chief, 12 associate editor. We have published about 100 articles, not 72, and we have a replication rate of 99%, which is a strong bias for all kind of reason I can explain later if you want. And on the next slide, yeah, so we distinguish between what we call reproduction and replication. Well, there's also a word you can read. I wrote a small article about that, but mostly what we call reproduction is you take an article with some code. It can be an analysis, a model, experiment, and you try to just run the original code. And what we call replication is when you take the article, you read the article, and you try to make a new a new implementation of the code, and you check, sorry, you check if you get the same results. And of course, the difficulty is that depending on the domain, to get the same result is very, very different. So for some domain in biology, maybe you only need some test to say it's okay, we got the same significance. And if you are, I don't know, in cryptography, for example, you want a bit for bit replication. And next. So this is what I just explained. So the base is replication. We start from a paper that has been published. It can be also a preprint. It's okay, and we try to do everything. And so it's a good exercise, especially for a student, because if you want to write a replication, so you have to read the original article to understand it, obviously. Then you have to try to re-implement the code, and you have to write a new article explaining all the problem you encountered. Because of course, when you try to replicate something starting from the article, you always miss some either parameter or some initialization, and so the idea is to to give all those details in the new paper. Next. And yeah, so we started on GitHub because we had no fund, no money, and it is still the case. So what we got from GitHub is, well, you know, we have a public repository, version control, and we and the chat. So mostly when you open an issue on GitHub, you can start, sorry, you can start chatting, and so it serves as a forum for during the review. And because we target most only computational papers, most of the time people are used to GitHub, so it's not a strong barrier for everyone. Of course, it comes with some maybe problem in the future because it's run by a private company, so Microsoft today, and it can close anytime. So in such case, well, we still have the fork of all the repository, but then it's a problem. But it has been run for 10 years now, and it's still, well, let's say it's still okay, but maybe at some point in the future we'll change platform. Next, please. So the review is totally open because, as I said, it's when you want to submit something, you open an issue. The issue are public, and so anybody can read the submission and the review, including the original authors. So in some case, we have the original authors that jump in during the review to provide further detail to help the replication. So it's not, so it means that you can read all the review for all the published paper on GitHub. Next. And so from our experience, at least for replication, it's quite useful. So here it is an example. So the first, the most important article, it's Guthrie and colleagues in 2013, and this is what started ReScience, because when I come to a new lab and I wanted to reuse this code and it was not available. And so mostly I asked my PhD student to rewrite the code, and then it was working. The model was nice. The question was, where do I publish such replication? And at that time, there was no journal interested in publishing something like this. So this is the reason we created the journal. And once you do that, then the new code can be reused by others. And since then, the new code has been served in a number of other works. Next. Now this is a few questions. So what kind of research we can replicate? So this is any domain. So it can be in biology, in physics, in chemistry, in humanities. We accept everything, but we need to have some editor to be able and reviewer to handle the submission. It's also something a good exercise for a student, for master students. So if you want to, yeah, you read a paper, you try to re-implement, and you have to write a new paper, and then you have to submit it and take into comments into account. Next. So if you cannot replicate a result, so I say that we have a strong bias because almost all the replication we have been published are positive, so people manage to replicate, and I think we have only one paper where it was not possible, and the reason is, well, twofold, that it's harder to show or to prove that something is not replicable because you can have several reasons why your code is not working. The other is that some people contacted me saying, oh, I know this paper is not replicable, but I don't want to publish it publicly because the original author is one big name in the field, and so it will be a problem for me, etc., etc. So it's not so easy to publish something that is not working. And one of the questions also we had for a long time was, can I replicate my own work? And first, our original answer was no, you cannot. And this changed in 2020. Next slide, because we organize a replication challenge. And so the idea is that you take one of your own paper that is at least 10 years old and you try to make it run. So it was a lot of fun because it really highlights all the problem we can have when we try to replicate all results. And it starts, of course, with all the libraries as a change, but it can go up to, okay, I have a disk, and I have nothing to read the disk. So in my case, it was a floppy disk, and it's really hard today to read what is on a floppy disk. So it was a yeah, good exercise to point the difficulty. So it's easy to replicate, let's say, for maybe for 6 months to 1 year, but in the long term, it's much more difficult. And the proof is that the first published article in ReScience, I am the author, and it's not working anymore just because of Python. So I use Python 2.7, and unless you go back to have a, I don't know, Geeks environment or Docker with Python 2.7, you cannot run it anymore. So this is one of the one of the conclusion.